Have you ever wondered what telescopes are like? I mean, they are like time machines because they let us see the past. The farther away we look, the older the past we see. The sun, like many stars we can see with our eyes, is in a galaxy called the Milky Way. But the Milky Way is not the only galaxy in the universe. Not everything we see in the night sky is part of the Milky Way. Some faint dots are entire galaxies themselves. You can never fully understand how big the universe is. The universe is so vast and huge that the human mind can't truly grasp its size. We might find the size of an elephant, a tree, or a building. But when we think beyond these sizes, our minds can't really understand. In this video, we want to show you a bit of the universe's greatness so you can truly feel how big is the universe. Or maybe we are small. Let's see. First, we reach the moon, which is about 384,000 kilometers away. If you drove a car at 100 kilometers per hour, it would take over 160 days to get there. From the moon, Earth looks like a small, delicate ball of blue and green in the darkness of space. This view makes us realize how small we are. Next, we head to the sun, which is about 150 million kilometers from Earth. This distance is called 1 astronomical unit. Light from the sun travels at 300,000 kilometers per second and takes about 8 minutes and 20 seconds to reach Earth. It would take around 19 years if you could fly to the sun in a jet at 900 kilometers per hour. This shows just how huge space is, even within our own solar system. The sun, a fiery giant, gives life-sustaining energy to our planet from very far away. When we look beyond Earth and the sun, we set our sights on Mars, our mysterious red neighbor. At its closest, Mars is about 54.6 million kilometers from Earth. But this distance can stretch up to 401 million kilometers when Mars and Earth are on opposite sides of the sun. To understand this, imagine traveling to Mars at the speed of a commercial jet. It would take over 50 years. This huge space between Earth and Mars makes space exploration very challenging. The rovers and probes we send to Mars face a long and complex journey because the distance is always changing. As we continue our journey to the farthest parts of our solar system, we reach Neptune, the distant ice giant about 4.5 billion kilometers from Earth. Neptune is the edge of our solar neighborhood. Sunlight, traveling through space at incredible speed, takes about 4 hours and 15 minutes to reach Neptune. This vast distance shows just how enormous our solar system is.
T-minus 10, 9, 8, 7, 6, 5, 3.
Launched in 1977, the Voyager 1 space probe shows humanity's endless curiosity and desire to explore beyond our known world. Voyager 1 has traveled for over 40 years and is now more than 22 billion kilometers from Earth, making it the farthest human-made object from our planet. It quietly drifts through space. In 1990, at the suggestion of the famous astronomer Carl Sagan, Voyager 1 turned its camera back towards Earth to take one last photo. This photo is known as the pale blue dot. From about 6 billion kilometers away, Earth looked like a tiny, faint dot in the vastness of space. Sagan used this image to remind us of our duty to protect and cherish our only home, a small speck in the immense universe. At the very edge of our solar system is the Oort cloud, a vast theoretical sphere of icy objects. This cloud might extend up to 100,000 astronomical units from the Sun, or about 1.9 light years, which is almost at the start of interstellar space. Scientists define the edge of interstellar space, called the heliopause, as the point where the sun's solar wind is stopped by the interstellar medium. Here, the sun's influence ends and the vast realm of interstellar space begins. The Oort cloud marks the final boundary of our solar system, a zone where the sun's influence fades and the journey into the galaxy starts. As we venture beyond our solar system, our next point of interest is Alpha Centauri, the closest star system to our sun, located about 41.3 trillion kilometers away. This is over 276,000 astronomical units, a distance so vast that the AU, useful within our solar system, becomes impractical. Instead, astronomers use the light year, the distance light travels in 1 year, for measuring such great distances. Alpha Centauri is about 4.4 light years away from us. Given our current space travel technology, a trip to Alpha Centauri is almost unimaginable. For example, the Voyager spacecraft, traveling at about 17 kilometers per second, would take over 70,000 years to reach this neighboring star system. This immense distance highlights the vastness of space and the challenges of interstellar travel. Our journey now takes us to the grand scale of our home galaxy, the Milky Way. The Milky Way, our home galaxy, spans about 100,000 light-years in diameter. This enormous spiral galaxy contains hundreds of billions of stars, each potentially hosting its own planets. Within this vast structure, there's a tiny area called the human radio bubble, extending about 100 light-years from Earth. This bubble represents the farthest reach of our radio and television broadcasts into space. Beyond this bubble, it's as if humanity never existed, as our signals haven't reached any civilizations that might be out there. The scale of the Milky Way is so immense that our entire recorded history is but a whisper in the cosmic wind, undetectable beyond this small bubble. As we leave the Milky Way, we enter the vast, almost incomprehensible realm of intergalactic space, where galaxies float in the cosmic ocean, separated by mind-boggling distances. Our galaxy is part of a small cosmic neighborhood known as the Local Group, a cluster of more than 50 galaxies spread across approximately 10 million light-years. The Local Group is a diverse collection of galaxies, including spiral galaxies like the Milky Way and Andromeda, as well as many smaller dwarf galaxies. The distances within the Local Group are so vast that light takes 10 million years to travel from one end to the other. This scale is far greater than anything within our own galaxy, highlighting the enormity of the universe. Intergalactic space is a quiet space between galaxies. In this huge emptiness, our galaxy, with all our history, is just a tiny dot among many, like one story in a giant library. Beyond our Local Group of galaxies, we find the Virgo Supercluster, a huge collection of many galaxy groups, including our own Local Group. The Virgo Supercluster spans about 110 million light-years in diameter, or 33 megaparsecs. This titanic structure contains thousands of galaxies from at least 100 galaxy groups and clusters, each with its own myriad of stars and planets. As we journey outward from the Virgo Supercluster, we arrive at an even larger cosmic structure, the Laniakea Supercluster. This massive group of galaxies, including the Virgo Supercluster, stretches over 500 million light-years. Laniakea, which means immense heaven in Hawaiian, truly fits this enormous structure, containing the mass of 100 million billion suns. Laniakea is a gravitational masterpiece, with galaxy clusters, superclusters, and countless celestial bodies all held together by gravity. At the heart of Laniakea is the Great Attractor, a mysterious area that pulls galaxies towards it with immense gravitational force. In this vast expanse, our Milky Way, the entire local group, and even the Virgo supercluster are just small parts of this gigantic structure. Laniakea gives us a deeper understanding of our place in the universe, showing we are part of something far greater than we can fully comprehend. At the edge of our cosmic exploration, we reach the limits of the observable universe, which stretches about 93 billion light-years in diameter. This raises an interesting question. If the universe is only 13.8 billion years old, how can it be so vast? The answer lies in cosmic expansion. Since the Big Bang, the universe has been expanding, stretching space and increasing distances between celestial bodies. What lies beyond the observable universe remains one of the greatest mysteries of cosmology. Some regions of space are expanding away from us faster than the speed of light, making them forever out of our view. Thus, the true size of the entire universe is unknown and could be infinite. The observable universe, vast as it is, might just be a tiny part of the whole cosmos. This humbling realization means there may always be parts of space, entire galaxies, and wonders we will never see as they move beyond our reach into the depths of the ever-expanding universe.